Now we'll see the experiment attenuation in optical fiber. The objective of this experiment is to study the length dependence of attenuation in the given optical fiber at different wavelengths. The components required are C-band laser 1, laser 850 nanometer, photodetector, SI photodetector D5, fiber spools on a different lengths. We'll get into the experiment. Attenuation in optical fiber. And this is the page. So here we have to choose 850 nanometer. The frequency, duty cycle and laser power are in the default settings. Look at this. So this is the 850 nanometer source. This has to be connected with the help of a single mode fiber cable and directly connected to the corresponding PD5 850 nanometer photodetector unit and the BNC connector with the channel 1 for DSO output checking. Just click on the start button. So we can see the waveforms generated here, right? So then remove the cable out from the PD and check the input power using the power meter. It shows 610, 612.8. Now remove and connect it here. And the power for this default settings, it shows 406 as its output power. And this is for 0.5 kilometer. So it's a very short cable length. It's a 0.5. So this same experiment can be checked with a different lengths 0.5, 1 kilometer, 1.5 kilometer and 2 kilometers. And we have a 2 kilometer spool in our hand. We'll just check with that. So connect the 850 nanometer source to the 2 kilometer spool and take another cable, connect it to the another end of the spool. The next end of the cable should be connected to the 850 nanometer. So we'll get the waveform and the corresponding output power 221 microwatt, and this will be calculated as the output power for 2 kilometer. Initially we'll check with the 0.5. So these measurements, these observed values with a different lengths can be taken, and with the help of this formula, attenuation formula and the attenuation coefficient, you have to calculate the attenuations. So this is the table. So for 850 nanometer, the fiber length you have to change from 1, 2, 3, 4, 5 and 6. Corresponding input power and the output power need to be measured with the help of optical power meter and the output which has been measured from this DSO, and the total attenuation need to be calculated here. By changing the connectors, like 1 kilometer can be connected along with another spool of 1 kilometer spool, number of connectors will be increased. So this is the number of connectors 2 to 4, and with that we can calculate the input power and output power, and the corresponding attenuation can be calculated here. And thus we have observed the 850 nanometer wavelength attenuation. And to cross verify, you can use any of these laser source, C-band laser sources, of 1510 to 1570. And using the same setup, we can use this C-band laser units. So with these sources, by changing the different length of the cable, we can cross verify the attenuations with the help of the formula. Thus, we expected the measurement attenuation coefficient in 850 nanometer wavelength is much higher than C-band wavelength. That can be measured from the calculation, after the calculation of the attenuation formula. Thank you.